Hey, it's Justin. When I'm stressed out and need a moment, I can be found in a safe space of noise-canceling headphones sweeping the shop. Well, things are a little bizarre in the world right now, and I need to put that energy into doing something more productive than sweeping. You know, a little organizing, or kaizening if you lean, tidying up if you condo.
Hello.
I have the perfect project. Let's distract ourselves with this wire rack of shame. It's been with me since the days of the garage, and I'm more than over it. It was a great inexpensive way to store a bunch of stuff, but now it's acting like a bad cubicle wall in the most important work area around our CNC. The wire rack has persisted for so long because it seemed to need a perfected organization system. Every time it's come up, one of us will inevitably say, it just holds so much stuff, which is a bad way of saying, this problem's impossible. Chris and I made this rough but surprisingly effective tool holder in about 10 minutes in our last shop. It is a great example of just getting something made that's a first version. Getting past that, it has to be perfect mindset, and we found much more utility in this than not having it all. First, let's find the largest common denominator of tool. Within that, we can make more specialized tool storage if needed. I'm looking at you, circular saw. The current divider holds the answer. Instead of waiting for a perfect solution, I just need to get something made. Try not to overthink it, and just get this wire rack out of here. I've learned that I need to break down big problems into smaller tasks. Otherwise I get stuck. So we know we want to move the tools over to the French cleat wall, and the big perk there is anything here can be rearranged real quick. Measuring these tools wasn't necessary, but it gave me a much higher likelihood of actually getting the dividers in this new shelf to fit the tools instead of having a bunch of gaps where we couldn't fit things. So while it seems like it takes a bit of time here, it definitely was worth it. We're going to use the same concept as the previous divider, except this time we'll make it modular. Fusion. Alright, so I'm going to go through the design fairly quickly. I use plenty of parameters, just a good way to work in my opinion, and I go through this in pretty good detail on a previous video called Learning Parametric Design. I'll put a card here. It may make more sense to go watch that and come back here and watch this, but you can also just follow along and figure it out as you go. Anyway, I'll share the F3D file on our website. If you check the description below for a link, you can play with the file yourself. We're going to open up that sketch. Essentially, you just want to start with a box and then dimension that. Come back in afterwards, after you've dimensioned that with some placeholders. Say you make it, 45 and 12. And then finish your sketch and go out and start making some parameters. So I've got a lot here. Again, I'm not going to go through this in detail. You can look at the file and check out that other video to kind of learn how this all works. But this makes it really quick to make changes somewhere down the timeline when you realize you don't have what you need, which is essentially how I designed this. I started making it, then measured all the tools and came back and realized, oh, actually, I need to change the height to be 15 instead of 14, and that's done very quickly. So you can use these as placeholders down the road. The basics of how this works is I made a box which has a border, and then inside of that there's some dados, the way the joints work here on the corners. So we'll use this sketch to make the rest of our project. We're going to extrude this top and bottom. So extrude, we're going to select that profile and that profile. Throw in this dado, and that's going to be important to do separate from the other one because we're going to use that as a pattern. Cut the top one as well because it's going to be separate. So we go up here to pattern, rectangular pattern, select features, and then you can select one of these guys, and anytime that updates now, instead of it being part of a body or trying to model in everything based on sketches, it will just pattern off of that one piece, as we see here. So we've got all our datas. We're going to model in the next part, which is the divider, the center divider in particular. So we're going to extrude that center all the way back to the back wall, make that its own component. Do the same thing for the divider on the side here, make it its own component. We're going to draw a sketch on the side here that's going to include some 5mm peg holes that we're going to pattern, and then also this little cord slot in the back just to run some cords behind all these here without really getting in the way. So we're using 5mm peg holes, and those align to the centers, and we're going to use a pattern on the next. After we extrude those, you can see we actually have holes there, and you can pattern that again. So think of ways to use patterns that aren't just sketches or bodies, and it's been a pretty effective tool for parametric design here. So I took those two and patterned up and down every 2 inches. Same thing for this guy. Then we cut out the back here, that little cord run. So it's looking pretty weird. We got one on the left here, we got one in the middle. The one in the middle is going to be fixed. That's why that's different. It used to be thicker. Put it in a divising plane and then modeled in, what is this? Oh, sides. Where did the sides come in? Let's go back there. The sides are modeled back in here, number 3rd or 4th option here. So it's the same thing. We should have made components, but we didn't. So there should be components that allow you to extrude those 2 pieces. Again, we're modeling this all tight, and we will work with CAM to do offsets for tolerances. So this pattern just looks at, the divider spacing and puts enough dividers in, which you could just leave this to do it in CAM, but to make a pretty model, we patterned that body over a few times with a rectangular pattern. Next, we have this nice modular grid pattern that we use on the outside of a lot of our pieces around the shop. It's a 3x3 grid of 7mm clear holes, and that effectively lets you use a 1/4-20 threaded nut on the back side, and you can mount anything to the other side. So you always have a grid to start from if you want to design something that kind of hangs off this, which I don't exactly have a plan for it, but I like to give us options because holes are effectively free when you have a CNC. So same thing, we drew half of this, we're going to mirror it. So we extrude those holes, and I had those go all the way through to the other side and just had them only affect the far outside pieces. We mirrored all those features to the top with that plane we made a back. Back is just an extrusion all the way down there. We combined out those 2 dados or rabbits in the back. Let's see how that works. And then we made a cleat, but that's just a 45-degree angle and enough length to kind of get enough leverage. We can screw in a bunch in the back here. I made this a little longer in the back so it had something to balance off of instead of slapping another piece of material, so that rabbit just kind of extended out. It worked really nicely. So all of these are just projected lines, and then we put in 3/16 holes for pre-drilled screws, and that way we could pre-drill into the dividers up above and easily put in screws that fit and lock the whole thing together without really any seams that are visible. So that's all that is just drawing all those around. Same thing in the back, pre-drill holes, extrude those holes. Got a lot of sketches going on. Made a box somewhere. Oh, we put that hole in the back. Anyway, you get the picture. We're essentially there at this point. One of the more interesting things is this plugin called Mapboards that we use quite a bit. It is a paid plugin, but let me tell you, it's definitely worth its money. I guess the only other thing here I did is threw in some shelves, which are pretty easy. So I'm going to make some others that are like 3 wide and maybe 1 wide, because we did end up using the 2 or 3 that I made that were double wide. But anyway, back to Mapboards. So Mapboards is this cool plugin. I just got the pro version. I think it's $25, but it essentially lets you nest parts based on their material. Those are my 3/4 parts and then my 1/2-inch parts. So we give it the size of the material we want to use. 48, 96, 48, 96. This is all shrunk down. Whoop. And then we say, well, we want to move the component bodies. We can do fill boards diagonally. We want the spacing to be this. We can do labels, which are kind of cool. We want that to be Y up for some reason. I don't know why that's what that is. Then we push OK. And what happens, this could maybe get messed up because I've already done this, is it throws everything on sheets for us. It's kind of a weird layout, but we'll take it. The one I actually used was a lot better than this, but it puts it on the correct thickness and usually flips the parts correctly so that the dados and rabbits are facing the right way, and links all that stuff. So if we would change any of these, dimensions, so we do 15 here, it should update and link all that stuff direct, which sometimes you have to move stuff. But if you do small changes, it's actually pretty useful. Saves quite a bit of time. Let me go back here. It does create a lot of parameters. I'll put a link to Mapboards. So that's what Mapboards looks like. That's what I actually cut. I did shuffle some stuff around, made it look a little nicer. But how we actually go and use this now is we don't set up cam typically in the same file. It's so multiple people can use a file. Somebody can be using the design file, somebody can be using the cam file. But it also just works a lot better because say you make some changes here showing a YouTube video, it doesn't mess up your cam file at all. So essentially what you do is type derive, and we want to select the map, and we'll select all those parts, and we'll create a new design. Okay. And that dropped in all of the parts that we wanted, only the nested parts. So anytime we save our other file, it's going to ask if we want to update. We'll call this the cam file. So we actually have made this. So I'll go to the other one we've actually used, and I included in the download file. And this is how I set up all my cam. And I did go through and edit a lot of things as I was working on revising the design. And I essentially had the cam ready to go, made a bunch of changes. Those all live updated, which is really cool. So all this cam stuff will be in the file as well. You could go through a lot of it, but essentially we drills first. We used a 3/8 inch down cutter to do a lot of the dados. We model everything tight typically, and then use cam to put in a little bit of a tolerance because material variance and machine variance and all that kind of stuff and things. So we use a negative 15 thou essentially. That's one side of each. Say it's a rabbit, it's only one side. It'll cut in there. That way, all of your stuff, when it gets put together, it'll actually fit. This is a really nice tolerance we've found for how we do dados. Instead of cutting this on the table saw, I decided to use a 45-degree engraving tool or a V cutter to hog that out and get a perfect miter without having to touch the table saw because that's how CNC people do. And then we do cutouts. And that's pretty much it. For the 1/2 inch pieces, I wanted to make more of them than I actually had modeled. I think I only had 5 modeled at one point. And so I ended up turning off a few of them that came through and then used a pattern, rectangular pattern, or I guess maybe linear pattern is what they call it in this. Offset that just enough so that this whole line just goes north here, 3 different pieces. So it'll go through and do all the drilled holes, and then it'll cut out this little guy, some tabs, goes through and undersized all of these 10 thou was not enough. So I probably would have done more. They were a little tight, especially on the top and the bottom, maybe 15, 20 overall would have been better. And then one thing we've been doing more of lately is coming back through and cutting off tabs, especially on these little guys, is just essentially using a 2D contour and selecting certain faces that we want to cut off and then set a small stock to leave. I did 1 thou radial, so it's not going to actually touch that face again, assuming you have good backlash and all those things. All you do is hold Alt, or I believe it's Option on a Mac, and maybe Alt on a Windows computer. I don't really know. And you can select only one face. And so I know there's tabs here and here, and trims those off. And if you turn off you do keep tool down and then turn off your ramps, it'll actually go through and cut in a row without having to pick up and go to the next one. So that's all of the cam essentially. Let's head out to the shop and look at how we set up tools. These things aren't pretty, but man, are they helpful. We've really taken to using them quite a bit. They really help to translate from the person doing the cam to the person doing the work in the shop. What's important. We like to highlight the stuff that you really shouldn't miss, and it really helps to get tools set up and the job started quicker. We keep a lot of our tools set up at the back of the machine if we can. This little plastic tray from Harbor Freight has been great to prep tools offline. We found it's a necessity to clean the collets and the tool holders every time you take them apart, otherwise they can bind up. We of course blow them out with compressed air, but that doesn't get everything, so we use this tool cleaner that I'll link below, and then use a brass brush to brush out every little piece of debris you can. Lastly, use a torque wrench when you're tightening your tool holders. That way you don't over-tighten them or under-tighten them, and everybody has a different perception to this. Follow me to the back of the machine where we set up tools while the machine warms up. Let me show you how easy it is to screw something up. So on this third tool, I put it above the tool forks, and I have no idea I do this until later when I'm tool hiding all the tools and it stops for no reason at all. Luckily, the machine alarmed out on a Z sensor, so nothing really happened, but it definitely confused me, and it's super easy to do. We are loving this tilt cart from Shop Carts. It goes up and down with a kick pump, but it makes it super easy to flip sheets onto the machine by one person. It could hold almost 10 sheets of 3/4 material, but we also just use it as a table half the time, and it's really nice because it's essentially a standing desk at the height you need it to be. Just a quick set of the Z0 here with a 1, 2, 3 block. I try to share all the reality I can, but it's tough when you have so many in one project, so I set the Z0 in the wrong spot here, and this 5mm carbide tip drill just bit it hard, and I was pretty confused for a bit, but figured it out eventually. I was pretty frustrated because this was literally the first operation on the first sheet, and I thought, man, I don't know if I can continue, but I ended up finding a fractional drill that would fit and do just the same thing. The mistakes are over, right? Nope, forgot to turn on the vacuum hold, so those holes were drilled incorrectly. After that, I think I finally got it going right. Let's listen to the sweet, sweet noise of compression cutter. Okay, that's enough. It's actually kind of terrible. So these parts are the dividers from AC pine plywood. One side's pretty nice, the other side's meh, it's okay. It's got a nice core though. So onto the 3/4. This is the same stuff, just thicker. First up is drilling. This is 3/16 inch high-speed steel drill bit. That's just all of our pre-drill holes. And then we go on to a 7mm drill, which is the pass-through for those 1/4 inch threaded T-nuts. Then we go on to dados. This is a Vortex 1340, which is a 3/8 2-flute down cutter. And those are because we're cutting smaller than 1/2 inch. Otherwise, we'd use a 1/2 inch tool, which is the 1350. This was running pretty conservative. We were only running 18,400 inches a minute. It could probably do closer to 500. And also the depth was pretty light. I'll stay quiet. You can just watch some dado cutting. The reason we cut the 1/2 inch first is we can take the 1/2 inch pieces and throw them in the dados to see if they fit while they're on the table. Then you can adjust your dados and cam if they need to be sized larger, but these fit just fine, as you can see. Now to the nicest and most accurate French cleat known to man. So here's the actual speed. It's like 50 inches a minute. I could probably speed that up, but I just don't like to push such an angled cutter that fast. There's no reason. Gotta get one for the gram. Now on the cutouts, we use a Vortex 3112, which is a mortising compression cutter, which means the upcut is shorter because we have dados, so we don't want to tear that out. And the first thing we always do is hit the smallest parts because they want to move the most, and this long French cleat's going to have tabs, so we'll start with that, and then move up the chain to larger parts, and eventually these long top and bottom pieces. Just a few more parts, and we will clean up the table and head over and start assembling this thing. First up, might as well sand it, since once it's put together, it'll be a little harder to sand the inside. Even though we're not going to do anything on the inside, it's just nice to have it sanded since this is such a rough plywood. I'm a huge fan of rounded quarters just in general in life, but especially whenever you're going to be pushing stuff in and out, you don't want a sharp corner, that'll catch, that'll splinter. So this is a tiny 1/8 inch radius roundover. The next day, the first thing up was assembly. And then coffee, of course. But wait, not in that order. Switch it around. I ended up adding a couple holes by hand that were missed in the cam. They're just holes for cords to run out the back directly. I opted to only glue the middle divider, as the rest just seemed like the screws would be plenty strong enough. Getting the first corner started is the hardest part. I used some clamps to hold it in place while I pre-drilled into the connecting pieces through the pre-drilled holes from the CNC. So I made a couple of rookie mistakes filming this. I filmed in 30 frames per second, which if any of you know, you have LED lighting, it's not flicker free, which ours isn't, we will get a nice wave effect when we speed this up. So sorry in advance. I'll try to do better next time. The great thing about pre-drilled screw holes is everything goes together just so easily. The dados help too, of course, but it's really just mindless and kind of an enjoyment to put together. And that was what this whole project was about, is trying to do something that made the shop a little bit better and, you know, takes our mind off of things happening in the world. And there we go. We have an assembled case. Let's try these dividers. A little bit tighter than I'd like, but they also won't come out when you pull tools out, so that's nice. And they do slide in and out with a little bit of movement. How's everyone doing? We're into 21 minutes now. It's a little longer than normal video. I figured it would be better to just keep going and get it all in one, but what do you think? Longer videos in the future or split it into multi-parts? Let me know in the comments. More roundovers. This portable Makita trim router has been indispensable for us. We essentially keep one loaded up with a roundover, and our corded one we keep with the trim bit in it for tabs and other things, but man, I can see having another one even. Let's sand. Hey, Margarita. Now for a little wood filler. I'm gonna fill all these gaps, make for what we're gonna do next a little nicer. I love this stuff because you can put it on pretty thick and sand it off and it doesn't leave any marks afterwards. So I love natural wood of all types, but for some reason I just had this deep urge to paint. So first, primer obviously, which covered up pretty nice and actually looked pretty good on its own. I almost went with just white, but I knew that would get filthy in this shop. Conventional wisdom would say, well, go with that blue you use for everything and all your tools are some form of blue. I don't know, for some reason I just had to go with something else. Maybe it was the colors I've been using in the model, but for some reason when I got to the hardware store to pick out paint, I just couldn't go with anything else but this. I know, it's a little brighter than I was imagining, but I do have a vision. There's going to be more painted things on the wall. This isn't going to be the only thing. It's also not going to be a rainbow, but we'll work on some complementary and tertiary colors that make sense. At one point when Joe turned around and saw what I was doing, he had very big eyes and said it looked like a park ranger's truck, which I agree. That's kind of a nice color in my opinion.
I guess it is pretty green. To me, it's not.
Alright, I guess I'm just being defensive now. In truth, I think there is a lot of benefit to Marie Kondo's principles.
Hello.
I mean, I'm not going to fold up all my clothes into tiny little pieces, but taking everything down and getting a blank slate again and looking at everything you have is a really good way to analyze and prioritize what's important. And especially in a shop like ours, we really need to think about what are we going to use most and where does it need to be. And this green cabinet is intended to be like the most used tools that need easy access and they're right at shoulder, chest high, so you don't have to bend over and grab them. We're going to extend that kind of idea through other tools and we're going to build some lower cabinets eventually here. But I think it's a good experiment and it was easy, very cheap, and so far I'm really liking it. This is something I love to do. Fiddle with things until I get them just right. Whether it's in the computer, a video, making something. I love this little place in time when you just gotta figure out how does this gonna work. Let's just throw caution to the wind. We're already at 25 minutes. How about a little Foley ASMR? Let's take a little tour. What a difference moving that wire rack makes. We actually have skylights right above this, and now you can get light all the way into where the computer area is. It's so nice. So I kind of just hid this from you, but we definitely didn't get rid of everything in the wire rack. There's still stuff left. We did a bunch of damage to 2 shelves, and there's really not that much in the rest of them, or so I like to tell myself. I think we can find some space for a lot of this stuff, and it should be gone here soon. Hope you enjoyed this little video. We're going to enjoy all our room for activities, and make sure and get those downloads at the link below, and see you in the next one.